Section 11.7 talks about graphing rational functions. So we can go 11.7, graphing rational functions. Now do realize that this graphing process is very basic. It's given to us a little simply done. Graphing rational functions can be extremely difficult, and many things can happen that even calculus has to explain or even work towards, and even sometimes there things get to be not so difficult to understand. So we're going over the basics of what this rational function would be. Now, one of the main things we start talking about with rational functions is we start talking about a simple fact that now we have x in that denominator. Okay, so we talk about x in that denominator. Okay, so I'm going to change this to be y equals a over x minus, let's see here, k plus h. Okay, so this is our overall rational function. And once again, this is based off our parent function. Okay, now do realize the overall graph, or the parent function right here, y equals 1 over x, was a graph where we had those two asymptotes and we had this curve in opposite ways right here. Okay, so this is the graph that we're working with, and we're going to start translating it around. So what we find out is we find out that our vertical asymptote, okay, so our vertical asymptote is x equals k. So whatever value is down here, this vertical asymptote, this dotted line going up and down that we can't cross right here, is whatever this opposite of this k value is. So if this is a minus 2, it's a positive 2 here. If this is a positive 2, it's a minus 2 right here. Our horizontal asymptote, okay, once again, this horizontal asymptote that was right here, is going to be y equals h. So it follows a transition of whatever this value is right here. Now, do realize that this is a horizontal line. Horizontal lines are in the form y equals. Vertical lines are in the form of x equals. So you can't just put the number right here. They are an actual equation to these lines. Also, A is our opening. Okay? So kind of like in the past, when A tells us our curve, it's doing the exact same thing here. Once again, when A is greater than 0, so I kind of discussed this in the previous lesson, when A is greater than 0, I can come down here, A is greater than 0. Okay, I'm just going to go quadrant 1 and 2. Okay, now do realize when I start talking about quadrants, I'm going to talk about my quadrants of my asymptote. So as I shift around, I'm up here in the first and there. I might have this line be shifted up, and I might be in quadrant 2, quadrant 1, and quadrant 4. But I'm going to call it quadrant 3 because it's how I am with my asymptotes. I'm in the upper right, lower left. If A is less than 0, we're going to be in that quadrant. It's quadrant 3 here, quadrant 2 and quadrant 4. Okay, so we see that if it's greater than 0, it's at 1 and 3, upper right, lower left. If it's less than 0, okay, I'll come here with an orange. If A is less than 0, we're going to be like this. Okay, so we're going to be in that upper left, lower right then for our graph, for our curve line. And this is how we start transitioning this graph around. So please do not overcomplicate this. Work with it as a basics, and do realize that we have undefineds, we have excluded values that we cannot have, and that's where these asymptotes come into play. So these are basically excluded values. Okay, so I can go like this. Let's go in here. This is okay, that's where we have those excluded values. Okay, it's where we don't exist. So let's look at number 9. Number 9 tells us that y equals 1 over x minus 2. Okay, so if we have y equals 1 over x minus 2, it does not tell us to graph it here. It says, what is the excluded value? So what is the excluded value? Okay, So the excluded value is basically what can't we have? We can't have this division of 0. So basically we cannot have x minus 2 cannot equal 0. So x cannot equal 2. So we see that the excluded value is when x equals 2. We can't have this. Okay? That's how we distinguish those excluded values, by what can't we have. We can't have division of 0. So whenever this denominator equals 0, that's where I have it, because we can't have it equaling 0. So it's an excluded value at 2. Number 13. Number 13. Let's see if I can draw this for you. I bring this up here a little bit. We have a vertical asymptote. We have a horizontal asymptote. And then they go like this and they say, okay, here is my curve. Okay? Tells us to write the equation here. Okay, or I'm sorry, identify the vertical and horizontal asymptotes. Okay, so our vertical asymptote is basically going to be x equals, our horizontal asymptote is going to be y equals. So this is always right here. Anytime told to identify vertical and horizontal asymptotes, you can go x equals, y equals for these. Just write this out right here. Now we look at the values at which we can have. X is that vertical line. We see we have a dotted line here when x equals 1. So our vertical asymptote is x equals 1. Our horizontal asymptote, we'll notice now y has a dotted line through -1 here. So y equals -1. And that's how we identify that vertical and horizontal asymptote on here. Next thing, let's go to some graphing with identifying the asymptotes. Okay, so we're going to go to number 15. Okay, now once again, here we are really not going to complicate these graphs. We are going to be moving through these rather quickly. So if we see 15 says that y equals 3 over x. If we remember back our parent function, our overall function right here was a over x minus k plus h. We notice we have a 0 and then a 0 out here. So we see that we have a vertical asymptote when x equals 0, a horizontal asymptote when y equals 0. And then if we go and graph this, well, x equals 0 is right here, y equals 0, and then a is positive. So that means I'm in the upper right and the lower left. And that's all we're going to do. It's going to kind of draw that curve like that, and that's it. Okay? Don't try to go too crazy where you go really close or way far out. That really requires some points to know a little more. I'm more worried about the basic overall shape of this. Number 17. 17 says f of x equals 1 over x minus 5. Okay, once again, vertical asymptote, horizontal asymptote, x equals y equals. If we consider this problem right here, that vertical asymptote, we're looking at the opposite of what's in here. Okay, once again, coming back to our formula here. We had that minus k, and it was this. Okay, so we go 5. And then we are not adding anything out here that we see, so that's where that 0 comes in. So now when we go and we graph this, we see at 1, 2, 3, 4, 5 on the x, we have this vertical line. And then we have the horizontal right here. Now we go back and we look at what a is. A is positive. So positive, so because it's 1 here, that's greater than 0. So that means we're in the upper right of our asymptote curves, and then the lower left of them. Okay, do notice I don't stay just in that third quadrant. I'm really kind of like we were to shift our axes around and make this be my third quadrant here. But I'm in that lower left of what my vertical and horizontal asymptotes are making. Looking then at 21. Okay, 21 kind of ties everything together here. 21 says h of x equals 2 over x plus 1 plus 4. Okay? So now we have our vertical asymptote and our horizontal asymptote. That vertical asymptote x equals horizontal asymptote y equals. We come here and that vertical asymptote is what can't we have for x down here? Or basically the opposite of this value. So we see -1. And the horizontal asymptote is what this value is over here. So it's 4. Okay, once again, coming back from that formula. I'm just transitioning that formula around. Where we're the opposite of this, and then whatever this is, it's telling us those asymptotes that we have going on here. So now when we go and we graph this, we have a normal x, h of x, or y plane. At -1 for x, so once again, this is my x-axis, so I go -1 on it. I have a vertical asymptote. At 4, we have a horizontal asymptote. And then now that we have our asymptotes graph, we come and we look at our value up here, our a value, and we see that this is positive. Because it's positive, once again, we're in the upper right, so that's right here, and then the lower left, so that's right here. Okay, now do realize that the only thing we cannot cross over are going to be our asymptotes. We can't cross over these, but this x-axis, y-axis, we can go through that. We can cross over into other quadrants. It doesn't have any influence on that. Okay, so do realize this is the basic of our curves, our graphs. Always remember that x has to be positive down here. If x is ever negative, you're going to need to factor this out and then move that up to that numerator. To kind of finish simplifying in here, but granted that's a little bit more complicated of a problem, but do be well aware that things like that can happen. Overall, our graphs are always transitioning right now off of this basic overall curve right here. So write down your vertical and horizontal asymptotes, graph those, and then you're going to be filling in either upper right, lower left, or you're going to do the upper left, lower right, once again depending upon if we have positive or negative value there.